Assalamualaikum everyone. Okay, in the previous video we have discussed about the second order differential equations. Okay, we have two types of the second order differential equations. The first one is we have the homogeneous second order differential equation, where the general form of the homogeneous second order differential equation is written as ay double prime plus by prime plus cy equals to 0. Okay, so the second type of the second order differential equations, we have the non-homogeneous second order differential equation. Okay, so basically the general form of the non-homogeneous second order differential equation is given as ay double prime plus by prime plus cy equals to rx, meaning here the right hand side is not equals to 0. Okay, so your rx not equals to 0. Okay, so for the non-homogeneous second order differential equation, we have another case where we need to modify the non-homogeneous second order differential equation. That is, we name it as the modified version. Okay, so we also have the modified version. Okay, when is the time that we need to use this modified version? Okay, we need to use this modified version, okay, if your yp equals to your rx. Okay, later on we will see in the next video how to use the modified version. Okay guys, in this video we will see how to solve the non-homogeneous second order differential equation and how to identify the yp based on your rx. Let's see for the non-homogeneous second order differential equations. Alright, so we have the general form of the non-homogeneous second order differential equations is given by ay double prime plus by prime plus cy equals to rx. So we have rx will not equals to 0. Okay, then we have three steps to solve the non-homogeneous second order differential equations. The first step is you will solve for the homogeneous second order differential equations. Okay, this is your first step, meaning you will write your ay double prime plus by prime plus cy equals to 0. So we will assume your ay double prime plus by prime plus cy equals to 0. So in these steps, you need to find the characteristic equation, and then you need to find what is your m. So m equals to what, and then lastly you will get what is your yg. Okay, so this is your target, that is you need to find your yg. Okay, so second step we will find yp. So what is yp? Yp is the trial solution. Okay, so trial solution. The yp, basically your yp will be, so yp will be the general form of your rx. So your rx can be any types of function. It can be maybe a constant or a linear function or maybe a quadratic function, and it can also be an exponential or trigonometric functions. Alright. Okay, so we have to find the trial solution yp, and we need to find the yp prime, meaning you need to differentiate, and also you need to find your yp double prime. So in this step you need to differentiate. Alright. Okay, so here you need to differentiate. Okay, next step, after you have found your yp prime, yp double prime, then you need to substitute into your original differential equation here. Okay, so remember in step 2 we want to find value of abc in your yp, Okay, lastly your final solution will be y equals to yg plus yp. Okay, so your yg will be the complementary solution and your yp will be the trial solution. Okay, now we want to identify the trial solution yp. Okay, before this I've mentioned that yp is the general form of your rx. Okay, meaning if your rx is a linear equation, then your yp will be the general form of a linear equation. and so on. Okay, so firstly, let's see for the function in the form of polynomial. Okay, let's say we have Rx is 4. Okay, so Rx equals to 4. 4 means it is a constant. So your Yp will be the general form of a constant. Alright, so we have your Yp will be equals to A. Alright, so we just write as a arbitrary value for constant. Alright, next. Okay, next, let's say we have Rx is x plus 5. So x plus 5 is a linear equation. So your Yp will be the general form of a linear equation. So your general form of a linear equation will be ax plus b. So this is for a linear equation. Okay, next. Okay, Rx is 2x. Okay, even if you have just 2x, okay, your Yp is still a general form of a linear equation. That means you will use the same Yp as before, that is, your Yp will be ax plus b. So for both examples, that is for the linear equation. Okay, next. Okay, let's say we have now is Rx equals to x squared plus 2x plus 3. So this is for a quadratic equation. Alright, so for the quadratic equation, the general form of a quadratic equation will be ax squared plus bx plus c. Okay, next example, Rx is x squared plus 3. Okay, so it is still a quadratic equation. So you will use the same general form as before. That is, your Yp is ax squared plus bx plus c. Okay, so the second one is for quadratic equation. Okay, next, Rx equals to x squared only. Okay, so x squared is also a quadratic equation. That means your Yp is equals to ax squared plus bx plus c. Okay, next. Next example is the function in the form of exponential function. Okay, let's see first examples. Okay, let's say we have Rx is 3e3x. So your Yp will be the general form of an exponential function which is equals to ae3x. Okay, so you will use the same power here, 3x. Right? Okay, continue next example. Rx is e2x. So your Yp will be the same form as before. So we have it is ae2x. So it depends on the power. Alright, next. Okay, Rx is e negative 2x plus ex. Alright, so you have two different exponential functions, meaning you will have two different terms of exponential functions for your Yp. That is, the first one, Yp is a e negative 2x, and then the second one plus bex. Okay, so next example, let's see for the trigonometric function. Okay, let's say we have the first example, Rx is 2 cos 3x plus sine 3x. Okay, the general form for the trigonometric function with the function of cos and sine, it will be a cos 3x plus b sine 3x. So it will be pair. Cos and sine will be pairing. Okay, so you will use the same angles. Alright, next. Rx is cos 2x. Okay, so even if you just have the cos in your Rx, but you will use the general form of your trigonometric function for cos and sine, it will be a cos 2x plus b sine 2x. Okay, next example will be sine of 4x. So this is supposed to be 4x, right? So your general form of sine of 4x, it will be Yp equals to a cos 4x plus b sine 4x. So you must have both your cos and sine. Okay, continue next. What if you have Rx is cos 3x plus sine 2x? So you have two different functions with two different angles. That is, the first one cos 3x, the second one is sine 2x. That means you will have two pairs. The first pair will be a cos 3x plus b sine 3x. Okay, so this one will be the first pair. The second pair will be plus c cos 2x plus d sine 2x. Okay, you have two pairs. Okay, next. let's see what if you have the combination. Okay, the first examples, Rx is x plus Ex. So we have that x is a linear equation and Ex is an exponential equation. So we have Ax plus B plus Cex. Okay, so you have here is a linear plus with the exponential function, right? Okay, continue next. We have Rx is 3x squared plus 2e negative x, meaning you have a quadratic 3x squared plus with the exponential function. So yp will be ax squared plus bx plus c, that is for your quadratic, and plus de negative x for your exponential function. Alright, continue. Next, x squared plus 1 plus sine 2x. So this one is a quadratic plus with the trigonometric function. Okay, so we have ax squared plus bx plus c plus d cos 2x plus e sine 2x. Okay, that is a quadratic plus with a trigonometric function. So this one is for the addition. Okay, even if you have the multiplication, even if you have minus in your Rx, your general form is always positive, right? Okay. Okay, next, what if we have multiplication, xex? Okay, so if you have the combination is a multiplication of two different functions, then we will choose one of the function to have their ABC or their constant. Okay, in this case we can use Liate. So we have here is x is an algebra. Okay, we have algebra and exponent. Okay, so basically only for algebra we will put the constant. Okay, so let's see, your yp will be ax plus b, so it is for a linear equation, times ex only. Okay, alright, so you just put for the algebra to have the constant a and b. Alright, next, Rx equals to x squared cos 2x. So you have an algebra, x squared is a quadratic, which is algebra, and you have a trigonometry. Still you have the algebra, so you just put a and b, or you just put the constant in your algebra function, in your quadratic function. That is yp equals to ax squared plus bx plus c, okay, times for trigonometric function you don't have to put the constant, so you just put times cos 2x plus sine 2x. Alright, last one, Rx is ex cos x. Okay, so you have exponent, and so we have here is exponent and trigonometric function. So since trigonometric function it will be before the exponential function, so we choose to put the constant in your trigonometric function. That is, we will have yp is ex times e cos x plus b sine x. That's all.